We're continuing our study on circles today by talking about angles within circles. So first, let's talk about some definitions. So what we call an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. Now the arc that lies in the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc. Now you can see here in this diagram, these two blue lines, those are chords of the circle, and they form this inscribed angle, the angle whose vertex is on the circle. Now highlighted in red on the circle, that is the intercepted arc. That is the arc that this inscribed angle intercepts. Now a central angle, on the other hand, is an angle whose vertex is the center of the circle. So for example here, we have angle RPS, and that is a central angle of circle P. You can tell this is different from an inscribed angle because the vertex of the angle is not on the circle, but on the center of the circle. Now an arc is an unbroken part of a circle consisting of 2 points called the endpoints and all the points on the circle between them. So for example here, we see this part that's highlighted in red, that is an arc, because this is an unbroken part of a circle. So it's only part of a circle, but it's one continuous section, and it consists of 2 points called the endpoints, so A and B, and all the points on the circle between them, and all the points between A and B. Now in terms of naming arcs, we have two types of arcs that we may see. The first is what we call a minor arc. This is an arc whose points are on the interior of a central angle. Now the central angle theorem states that the measure of a minor arc is equal to the measure of its central angle. What does that mean? Here we see that there is a central angle, ABC, and it has some measure x degrees. Now we would say, according to the central angle theorem, that the measure of arc AC, that's what this M with capital AC with a little arc over it means, the measure of arc AC is equal to the measure of that angle, ABC. So that is also x degrees. Now a major arc is an arc whose points are on the exterior of a central angle. So that means that the measure of a major arc is going to be equal to 360 degrees minus the measure of its central angle. So here, for example, the measure of arc ADC, that's the major arc, is equal to 360 degrees minus whatever the measure of angle ABC is, which would mean this is 360 minus x. So if x, for example, were 70 degrees, then the measure of the major arc would be 360 minus 70. Now, if the endpoints of an arc lie on a diameter, then we call the arc a semicircle. The measure of a semicircle is going to equal 180 degrees. Here's an example. The measure of arc EFG is equal to 180 degrees here. So this red part that's highlighted on the circle, we would say has a measure of 180 degrees. Now in terms of naming arcs, we've already seen minor arcs and major arcs, and you may have noticed this already. But generally, we would say that the minor arc that's associated with that angle ACB, we would call arc AB, whereas major arcs and semicircles are generally named by their endpoints and a point that's on the arc. So you'll usually use 3 letters to indicate a major arc. So the major arc that's associated with angle ACB, we would name ADB. So purely from a naming standpoint, without even looking at a picture, you should be able to tell if you're looking at a minor arc, something that's less than 180 degrees, or a major arc, something that's 180 degrees or higher. Let's take a look at example 1. find the measure of each arc of circle P, where RT is a diameter. So let's start with arc RS. So you're looking at this angle that's formed by RPS, and we see here that that angle is 110 degrees. Since RS is a minor arc, we would say that the measure of arc RS is the same as the measure of angle RPS, which is 110 degrees, which is less than 180 degrees. Now let's find the measure of arc RTS. Simply from the name, we can tell we are looking at either a semicircle or a major arc. So we're looking at RTS. So we see here we're looking at a major arc. To find the measure of the major arc, we would do 360 minus the measure of the minor arc, which we just found is 110. So 360 minus 110 is equal to 250. All right, and C, RST. What's the measure of arc RST? Well, looking at this, we see here that RT is really just the diameter because it goes through the center of the circle P. That means that RST is a semicircle, which means that the measure of arc RST must be equal to 180 degrees. The next thing we're going to talk about is the inscribed angle theorem. Now this theorem says that the measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. So here's a picture. And what we're saying here is that whatever the measure of arc AB is equal to, which we know the measure of arc AB is simply the measure of the angle that's formed by ACB, which is not drawn in here. But once you have the measure of arc AB, if you find half of that measure, that gives you the measure of angle ADB. That's the inscribed angle. Recall that the inscribed angle is an angle whose vertex is on the circle, not on the center of the circle. Take a look at example 2. Find the measure of angle T. Now if you see here, the measure of arc RS is given to us as 48 degrees. Because angle T is an inscribed angle and RS is the arc that it intercepts, we know that angle T must be equal to half of the measure of arc RS. So 1/2 of 48 degrees is equal to 24 degrees. So the measure of angle T is 24 degrees. Next, find the measure of arc QR. Now, to find the measure of arc QR, we may need to find a few other things. Notice how we're given that angle QRT is 50 degrees. Since we know that's 50 degrees and that is an inscribed angle, we know that the arc that it intercepts must be twice that, because this must be half the measure of the arc that it intercepts. The arc it intercepts is TQ. That means TQ must be equal to 100 degrees. Once you have that, we can also notice how TR is the diameter, which means that arc TQR must be a semicircle. Since we know the measure from T to Q is equal to 100 degrees, and we know the measure of the arc TQR is 180 degrees, we can find the measure of arc QR by subtracting 180 minus 100. So that gives us 80 degrees. So the measure of arc QR is 80 degrees. Example 3. Find the measure of arc RS and the measure of angle STR. What do you notice about angle STR and angle RUS? So, we know that the measure of arc RS has to be equal to 2 times the measure of angle RUS. Since RUS is an inscribed angle and the arc it intercepts is RS, that's how we know that the measure of arc RS must be twice the measure of that inscribed angle. So that would be 62 degrees. Now, since we know that this is 62 degrees, if we're trying to find the measure of angle STR, we notice that the measure of angle STR must be half the measure of the arc that it intercepts, which is the arc we just found, arc RS. So the measure of angle STR must be 1/2 of 62, which is 31 degrees. So what do you notice about angle STR and RUS? They're actually equal to each other, and the reason that is the case is because they both intercept the same arc, so they are both half the measure of arc RS. We have one more theorem to talk about, and this is when we have a right triangle inscribed in a circle. Now, if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. So here's a picture. This is saying that if we have a right triangle ABC inscribed inside a circle, then the hypotenuse, AC, must be a diameter of the circle. The converse is also true. So if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle. Now the reason this is true is because if angle ABC is 90 degrees, that means that the arc that it intercepts must be twice the measure of that angle, which would mean that is 180 degrees. If it's 180 degrees, that means it is a semicircle, which means that AC must in fact go through the center, which then makes it the diameter of the circle.